All right, math fans. This is Mrs. Hunter. I have such a cold, and my throat hurts so bad that I now sound like my husband. No, I'm kidding. This is Mr. Hunter. She has strep throat, so I got this. So here you go. Similar figures. We're gonna talk through this a little bit. Two polygons are congruent if their corresponding angles are congruent, and the lengths of their sides are congruent. Basically, if the angles and the sides are congruent. Polygons are similar if their corresponding angles are congruent. So the angles have to be congruent, and the lengths of their corresponding sides are proportional. Is it proportional? Or is it pro? Yeah, I think it's an O. Proportional. Symbol for similarity is this little sideways S-looking thing. Okay? The sideways S-looking thing that we put on top of the congruency statement, that's for proportional. Okay? So here we go. First things first. Are these triangles similar? You have three pair of corresponding angles are congruent. Well, I've got a 50 and a 50, so the C and the Z go together. I got 100 and 100. The A and the X go together, and the 30 and a 30. So yes, three pairs of corresponding angles. They are congruent. Check. Are the three sides proportional? Okay, so basically what I'm going to do is I'm going to take one and divide it by the other. So I can do, it's called your scale factor. So I'll do the larger divided by the smaller. So that's 5 halves. Okay. So I went from my 50 to my 100. So my 50 to my 100 is 5 halves. Then I'll go from 100 to 30. So 100 to 30. 7.5 over 3. 7.5 divided by 3. Wow, that's kind of interesting. 7.5 divided by 3 is also 5 halves. That should reduce down to 5 halves. And this last one, from the 30 to the 50. Let's do that in a different color. From the 30 to the 50, B to C, and from the 30 to the 50. That's 10 divided by 4. 10 divided by 4. That also reduces down to 5 halves. So all of them have the exact same proportional. So yes, ABC is similar to XYZ. Now, one thing I will say about this, it is very important that when we write our statement, that the angles correspond to each other. So like A is congruent to X. A is your 100, X is your 100. B is congruent to Y. B is your 30, Y is your 30, and so far and so forth, so on and so forth. C is to Z, C is to Z. Just like your congruency statements, all angles need to line up with each other. And that also goes along with the lengths now. So A to B is proportional to X to Y. So A to B, that 3, is proportional to X to Y, the 7.5. And so on and so forth. Okay? And you'll pick up on that. If that confuses you, you'll pick up on it eventually. But we'll start there. The common ratio between all of these is called the scale factor. Okay? Example 2, the scale factor in number 1 is 5 halves. All right? 5 halves is because that's what I have to multiply the original by to get the new one. Okay? I have to multiply the 3 by 5 halves to get to 7.5. Okay? What is the perimeter of ABC? Okay. 4, 5, 6, 7, 8, 9. What is the perimeter of XYZ? 10, 15 plus 7 is 22.5. Is 22.5. 2.5. What is the ratio of their perimeters? Well, it should be 5 halves. Well, that's 22. What's 22.5 divided by 9? Let's do 22.5 divided by 9. Let's double that. That's 40. 20.5. That's 45 over 18. Divide both of those by 22. No, it's not. 22 times 22 is 44.5 is 45. Okay. 45 divided by 18, divided both by 5. That's 5 halves. Oh, look at that. The ratio of their perimeters is 5 halves. The ratio of the perimeter is the same as the scale factor. Who'da thunk it? Okay. If two polygons are similar, I have to spell it phonetically, then the ratio of their sides, I'll say side lengths, is equal to the scale factor. Okay. What would be the scale factor of two congruent polygons? Well, if I got two congruent polygons, what would I have to multiply the first one to get to the second one? So if this is 2, 3, and 4, when this one's 2, 3, and 4, to go from one to the other, I would multiply it by 1. That would be the scale factor from two congruent polygons. Cool. All right, let's keep rolling. Page 2. If a polygon ABCD is similar to polygon FGHIJ, then A is congruent to, again, remember, first one congruent to the first one. A is to F, B is to G, C is to H, D is to I, and E is to J. Okay? And the proportions are true as well. What this is saying is A to B is proportional to F to G. B to C is proportional to HG to H, and so on and so forth. That would be that one. And it goes all the way down the line, even if you went wrap back around. So if I said, let's pick a different color. Ooh, that's kind of a hot, weird one. Even E to A, or A to E, if you want to put it that way. A to E would be congruent, would be proportional to F to J. That's what that one last is, even if you wrap it all the way around. Okay? So here we go. Let's do this. A to B divided by F to G. A to B to F to G. That'd be 6 divided by 4. That's 6/4, which is 3 halves. B to C over G to H. B to C over G to H. That's 12 over 8. Which divide those by 4. That's again 3 halves. So the scale factor must be, I'll write right here, 3 halves. Okay? And again, in the next one it says, note that the vertices are listed in corresponding order. If we wrote this instead, say if we put this one first, okay, the scale factor would actually be flipped. It would be the reciprocal. It would be 2/3 instead. Because that's what you have to multiply. Did I do that backwards? FG. Yeah, so that's what you have to multiply one to get to the other. 4 times 2 divided by 3. 6 times 2 divided by 3. 4 times 2. 6 times 2 is 12. 12 divided by 3 is 4. 4 times 2 is 8. 8 divided by 3 is not that. Okay, the scale factor is not that. Okay. Let me pause before let me figure this out real quick. Okay, so here we go. You're right. It should be flipped. The 3 halves would flip to 2/3. However, when finding the ratio, we need to go back and adjust every last one of these. So let's go back and do this again. Now that we've seen how to do this, let's show you how to do it right. When you are finding the scale factor, what you're supposed to do is you're supposed to divide the new one by the original one, which means you would divide FG by AG instead. So what really should be happening is not that. These are all flipped, every last one of them. Okay, you should divide the new one by the old one. So we will blame, I don't know who will blame on this one, but go with it. So the new one is FG divided by AB. So let's go back here. FG is 4, AB is 6. So that's 4 over 6, which is 2/3. All right, 2/3. Okay. B, C, and GH the same way. Flip them. So GH over BC. GH is J. GH, what am I looking at? GH is 8. 8 over 12, which is again 2/3. So the scale factor should be 2/3 now that you've used half your eraser. So to go from the big one to the small one, I would multiply by this scale factor. All right, 6 times 2 is 18. No, 6 times 2 is 12. 12 divided by 2 is, divided by 3 is 4. All right, and then if we went the other way around, we have to flip it. So this would be 3/2. All right, to go this way. 8 times 3 is 24. 24 divided by 2 is 12. All right, cool. So let's talk about these for just a second. Are the polygons similar? If not, tell why. If so, write a similarity statement. So first things first, here's what we're going to do. We are not told about the angles. I do know that these are true, but if we can figure out the sides, we can go from there. So let's just start going from it. Let's go this way. Let's do small to big. So I'm going to go 8 divided by 12. That's FG over AC. 8 divided by 12. That's 2/3. Let's do 10 divided by 15. 10 divided by 15. Well, that's also, divide them both by 5. That's also 2/3. 6 divided by 9. Well, 6 divided by 9 is also 2/3. Okay, so to go from this triangle to that triangle, we would have to multiply by 2/3. All right, so we have triangle ACB is similar to triangle EFG. EGF. Okay. No. So I started with the angle that I knew was the same, and then I went in the same order around. The middle side, the bigger side, the smaller side. The middle side, the bigger side, the smaller side. I could have started here and gone around. If I'd have started labeling this one the BAC, I would have started here as well, FEG. Doesn't matter where you start, so long as you follow along the same pattern with the other one. Okay, I'll do the next one and kind of let you do the last two on your own. All right, so parallelograms. Yay, parallelograms. So parallelograms, 105. If I got a 105 in this corner, that means this corner is also 105, and that means these two are corresponding. 180 minus 105 is 75 degrees, which that should tell you something right off the bat, that this does not match this. So the answer is no. And you can say, because corresponding angles not, well, I probably should say in decent English. What am I doing? Are not congruent. Are not congruent. All right, here's what I want you to do. I want you to pause the video and finish the rest of the page out. Okay, and then I'll just work through it real fast. All right, yeah, so here are the answers. So first things first, this one right here, the first one is yes. What you should know is that all three of these sides are congruent, therefore all three of these are also congruent, they're 60s. If these are all congruent, they're also 60s, so by definition, all of these angles are 60s. By definition, all three of these sides are the same, so these are similar triangles because they're both equilateral. All right, these two are not, because everything works out except for these two sides. We do not know if they are the same length as these. They don't look like it. They still might be. Don't look at looks. And maybe it's deceiving, but don't depend on the scale factor. But we don't know if these two match those two. All right, so we can't say. Last but not least, I know I'm missing some down here, but they said these are similar, so you just go off the fact that they're similar. I marked the congruent sides, the congruent angles, and I just went around in a circle. So I said JX, whatever that is, IG, and I started 1, that's the 2 mark came around, so whatever that was, N, Y, L, M, K, all right? And since I went from this one to this one, I got to divide the other way around, so MK is 15, so 15 divided by 10, the corresponding center here, so that's 3 halves. And then if I went on to this one, the way the ratio factor is to go from the original to the other one, you multiply. To go from that one back, you divide. So if I knew this one, 8 times 3 halves is 12, or 12 divided by 3 halves is 8. All right? Which, remember, divide by a fraction. If you divide it by a fraction, you flip it and multiply. So that's really 12 times 2, which is 24, divided by 3, which is 8. All right, that's how you do it in your head real fast. All right, let's turn the page. Actually, at this point, I'm going to let you kind of go on your own. I'm going to fly through these real quick. I want you to go until you get to this spot right here, because I think you can do all this on your own up to that point. You probably back up there. You can probably even figure out this right here on your own. So I'm going to work real quick and just go. Okay, so if you want to pause and try it on your own, go for it. Otherwise, here we go. Which two triangles are similar? Name them by writing the similarity statement. Okay, so I'm basically going to take. I'll start with this. That's the shorter. That's the shorter. That's the shorter. That's the middle. Oh, no, that's not the middle. Middle. Different color. Middle. Middle. Large. So we're going to look for similar sides. So let's check these two. That's 9 over 5. For the small one, that would be 21 over 9, which that does not reduce down to 9 over 5. So I can already tell you the first two are out. Let's try the first and the third. So that would be 9/3 for this. Let's look at the small one first. 9 divided by 3 is 3. The 21 divided by 7 is 3. Let's do the middle one. 15 divided by 5 is 3. So we'll call these. We'll say. So I'll start. That's between the small and the large. That's between the small and the large. That's between the large and the medium. That's between the large and the medium, and that's between the medium and the small. So we'll say we did that one. We did this one divided by that one. So we got to say it backwards. So triangle GIH is similar to triangle ACB. Cool. Yeah. Are the two triangles similar? Show your work. Justify your answer. All right, same idea. Start with one divided by the other. So I'll do this one divided by that one. So 8/5. Ooh, I don't know that for sure. Let's make sure we mark them. Small, middle, large. So you gotta kind of split them up right. So small divided by small. So that's 8 divided by 5. So 8/5. Middle divided by middle, that's 16 divided by 8. 16 divided by 10, which is also 8/5. Large divided by large, 20 divided by 12.5. So let's double that. That's 40 divided by 25. Divide that by 8, that's 8/5. So yes. Because all sides are proportional. All right, one thing you will find, if all sides are proportional, then by definition, all the angles have to be congruent. So that's between the small and the large, that's between the small and the large, that's between the large and the medium, that's between the large and the medium. Okay? And since I went this one divided by this one, if I were going to write my statement, I'd have to start with this one over here. So that would be triangle. Oh, I don't have letters at all, so forget it. I haven't. Find x and y. Okay, so these are two similar triangles. I've got this triangle right here, and I've got this triangle right there. Okay, those are similar triangles. And since these are parallel, this angle and this angle is congruent. This angle and this angle is congruent. And they share this one up here. And by the reflexive property, we know that angle A for one triangle is congruent to A of the other triangle, since they share it. So they have congruent angles, therefore they are proportional. These are similar triangles. Okay? So, without further ado, let's figure out the proportion. So, we'll do big divided by small. Okay? So, here we go. That would be this side, the entire side. 16 plus 8 is 24. So that's 24. That's the big side divided by 16. That's the little side. Divided all by, 8. That'd be 3 halves. That's your scale factor. Okay? So let's do this one. So the entire side is 20 plus y divided, and then the small side is 20. So that'd be 20 plus y divided by 20 equals 3 halves. Kill. So that's 20 plus y equals 60. 2 times 3 is 6. Yeah, 60 divided by 2 is 30. 30 minus 20 is 10. Therefore, y equals 10. So there's that piece. Y is 10. Cool. And you can do the same thing here. Big divided by small. I'll do this one in green. Big divided by small. So 30 divided by x equals 3 halves. All right. That means 60 equals 3x. 60 divided by 3 is 20. Yeah, x equals 20. All right. Keep going. Find the values of these variables. Yeah, I'm going to pause and just put this up there. I don't feel the need to watch me through it. All right, there's those two. If you want to look over what you've done, pause the video because I'm about to move on. All right, I'm moving on. Let's see here. Oh yeah, I'm going to pause and just work on these. So you may want to pause the video if you're going to do it on your own. Okay, there's this side. Yeah, I decided to use the letters over here to kind of make it a little clear. I don't know what Miss Hunter is actually going to require on this, but yeah, x would have to equal 8 because x is proportional to x plus 4. That's where this piece comes in right there. And this one is simplistic enough. I hope you can get it. Basically just, you got your vertical angles, and then by definition the last two have to be true. All right, I do want to explain this real fast. I feel like I need to. The line, basically, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides them proportionally. Therefore, basically what this is saying, if this is x and y, and this is a and b, then x over y equals a over b. Basically, this proportion equals that proportion, is what it's saying right there. Okay, those are equivalent proportions. So if you want to just try these on your own, go for it. But I'll walk you through the first one real quick. So this is actually a 16 down here, and this one's a 10, even though it cut it off on my PDF. So basically what we've got is you got x over 16 equals 5 over 10. So that's 10x equals 5 times 16 is what, 80? Yeah, 6 times 5 is 30. Yeah, 80. And then therefore x equals 8. Okay. Same thing over here. We had, I'll just draw it again. So you had x plus 1.5 on here. We have x, and then we had 2.5. That's what your version looks like. All right. So see if you can try it on your own. Pause it, see if you can try it on your own. But I'm gonna start working it out right here. So we've got x plus 1.5 over x equals 5 over 2.5. So just cross multiply 2.5 times x, that's 2.5 x. 2.5 times 1.5, I don't have a calculator on me. 2.5 times 1.5, 5 times 5 is 25. 5 to 2 is 10, plus 2 is 12. 1 times 5 is 5. And that's 2, so that's 5, 7, 3. 3.75 plus 3.75 equals 5x. Subtract 2.5, 3.75 equals 2.5x. 3.75 over 2.5 equals x. Yeah. I feel like there's an easier way of doing that. Is there a calculator on this Mac? Pause. So 1.5 equals x. Yeah, cool. Let's turn the page, see if we know how to do the other two. So there's those. Yeah, I think this is what was supposed to be. Oh, good night. This thing printed really weird. Yeah, these were supposed to be up there. Okay, anyways, do number 3 real quick. Pause the video, do number 3. Actually, it turns out they are proportional. Alright, so because this is the same proportion as that, we know these are proportional. So just going the other way. Alright, so this basically... Alright, so if I've got 3 parallel lines, or more, I can have a 4th parallel line, and a 5th parallel line, and a 6th parallel line, so on and so forth. Basically what this is saying is that all 3 of the sides are proportional. So A is proportional to B, C is proportional to D. This one, X, would be proportional to Y, and all sorts of stuff in between. Even the 3 lengths here would be proportional to each other. There is a way to find that. But I can't work this out because I don't have it with me. Give me a second. So basically, I'm going to work example 1 and 2 right on this page right here. So example 1 has 4 and 6 and 5 and x. Basically, again, I can do the left side is to the right side. Or you know what? I really could do the top 2 are proportional to the bottom 2. It's all sorts of things I can do with that. It's very, very flexible. So I'll say 4 over 6 is proportional to 5 over x. So that's 4x equals 30, x equals 7.5. Okay? And the same thing will be true with the other one. So let me delete this real quick. So if I did x, and this whole thing right here is 24, 8, and 12, not y, 12. So basically I can say, hey, look, this entire side is also, 8 and 12 is not 24, it's 20. Whatever. So I can say x is proportional to 24, and 8 is proportional to 20. And just go about it on that route. All right, so that's 20x equals 24 times 8. 8 times 4 is 32. 8 times 2 is 16, 17, 19, 192. That's 192. Yeah, 192 divided by 20 divided by 20. That's what? 5, 10. That would be 9. So it's 180 with 18 left over. Yeah, I don't feel like doing. Why am I trying to do this long term? Clear 192 divided by 20 equal. No. I hate the calculator on my phone. 9.6. X equals 9.6. Cool. That's what this bad boy would have to equal right there. Let's turn the page. Is there not another one over here? There should be. Okay. The angle bisector theorem. Okay, so if a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportions to the other 2 sides of the triangle. Basically, if these are the same, all right, then... Ooh, give me a second. Okay, I had to remember what I was doing real quick. So let's say x to y, those two are proportional to a to b, all right? So x is to y as a is to b, and you can flip those, put y over x, b over a. I'm pretty sure you can even do it this way. X over a is proportional to y over b. That would work as well. There's many ways you can work with proportion. So, but I like to stick one. I like to put one side against the other. It just makes I just remember it easier that way. So and this time I'm gonna put p on top because I don't feel like doing that. So that's p divided by 12 equals 5 divided by 10. So p equals 12 times 5 is 60. 60 divided by 5 is 12 times 5 is 60. 60 divided by 10 is 6. I'm tired. What are you gonna do? Cool. The next one, I can do the same thing. Let's do x over 6. So that's x over 6 equals, what about this side? This would be the entire side minus x. So it would be 6 minus x over 4. All right, so I got 4x equals 36 minus 6x. Add that over 6, that's 10x equals 36, x equals 3.6. Cool, so you can do the last one on your own. Pause the video, see if you can do the last one. This video is getting way too long. So here we go, I'll do 10x minus 4. I just want to put the x on top. So 10x minus 4 over 6 equals 20 over 5. Miss Hunter is going to be pissed at me because I'm sure I'm nowhere near as specific as she is. 5x, nope, not 5x, 50x minus 20 equals 6 times 2 is 12, so that's 120. 50x, what? 50x equals 140, x equals 1.8. 14 divided by 5 is 2.8. It's like, that doesn't sound right. 2.8. 2.8. Cool. And that might actually be the last page. Oh, there's 2 more on there. So you can do the last 2 on your own. Alright? Pause. Okay, I'll put the last 2 up here real quick. We got one triangle. You can marvel at my artwork. See, isn't it glorious? 6, x, 8, and 10. So x is to 8 as 10 minus x is to 6. So that's 6x equals 80 minus 8x. 8 plus 6 is 14. Yeah, 14x equals 80. 80 divided by 14 is something really, really ugly. Yeah, that's a non-repeating decimal. So let's just cut that in half. Let's do 40 over 7 because that's more specific. Then the other one. There's that one. Let's do the other one real quick. Again, you can marvel at my drawing abilities. So this one looks like that, sort of. No, let's do that then. That is congruent with that. So I got x plus 2, x plus 5, plus 9, x plus 3. Oh my gosh, this is going to be a quadratic. Why are we going to do this? So I'll do it the same way. That is to that. So I've got, here we go, x plus 2 over x plus 5 equals plus 3 over x plus 9. Therefore, I got x plus 2 times x plus 9 equals x plus 3 times x plus 5. Alright, so that's x squared plus 11 plus 9 times 2 is 18 equals x squared plus 8x plus 15. The x squareds cancel out, which is okay. You're canceling out the negative root, so that works out. So subtract the x, 8, 9, 10, 11, so that's 3x equals... Ooh, this may be a bad problem. Basically what I'm doing is I'm subtracting the 8x and I'm subtracting the 18 from the 15, so that's negative 3. X equals negative 1. Yeah, it can equal negative 1 because when I plug it back in, negative 1 plus 2 is 1, negative 1 plus 5. When I plug it in, all sides are still positive. Ooh. Let me pause. Let me get the master's permission real fast. Okay, I checked with the master just to be sure. It is okay that we cross these out because those will give us, those would either yield, what do you call it, imaginary roots or roots that would lead these to be negative numbers. So There we go. You have it. Have fun. It was a pleasure talking with you. Don't have too much fun with the rest of your period. Bye.